So, how does a software developer stay on top of their game for, I don't know, 5 years? 10 years? How about over 3 decades? We're about to dig into a career that started with computers the size of a room and is now right at the cutting edge of AI. Honestly, it's a masterclass in navigating non-stop change.
Just look at this timeline. It maps out a journey from 1988 as a mainframe apprentice in a jewelry factory all the way to 2025 as a director of innovation working with AI and the cloud. This isn't just a career. It's basically a tour through the entire history of modern computing. The big question isn't just what changed, but how in the world did one person adapt through all of it?
All right, here's how we're going to break this down. We'll start way back with the skills learned on the mainframe. Then we'll follow the big pivots during the internet boom and the rise of mobile. We'll see how he mastered the modern tech stack, and then we're going to uncover the one single thing that made this whole 35-year journey even possible.
Okay, let's wind the clock all the way back to 1988. In this world, computers weren't personal. They were these corporate giants. All the power was locked up in massive, room-sized machines. We're talking a world of batch processing and green screens, a world that was about to get turned completely upside down.
So, our developer's story kicks off as an apprentice at a German jewelry factory. This reference letter from 1902 actually talks about his first job, which started back in 1988. He wasn't coding on a MacBook, he was programming a Unisys mainframe. He was writing in languages like COBOL, which was the engine of business and banking, and assembler, a super low-level language that let him talk directly to the hardware.
This quote just paints such a vivid picture, doesn't it? We're not talking about a tiny, silent SSD. We're talking about hardware the size of a washing machine. Actual mechanical beasts that you had to physically open up to swap out the data. It was a totally different, much more physical relationship with technology.
And forget about your slick, modern code editor. Back then, the toolkit was physical. You had punch cards for your data, these huge 8-inch floppy disks just to boot the system, and debugging, that meant printing out stacks of paper, literally marking errors with a pen, and then going back to manually type in the fixes. Every single step was slow, deliberate, and hands-on.
But that whole world of centralized computing was about to face, well, an extinction-level event. The rise of the personal computer and the internet. Suddenly, mainframe skills were looking like they belonged in a museum. To survive, you had to pivot, and that meant embracing a completely new way of thinking about computers.
And the scale of this change was just immense. Computing power went from one giant machine to thousands of individual desks. The languages totally shifted, from procedural stuff like COBOL to object-oriented powerhouses like C++ and Java. And those cryptic green screen terminals, they gave way to the very first graphical interfaces. It was a complete and total paradigm shift.
And here is that pivot, right in action. This reference from the late 90s shows him working in a field that was brand new, mobile computing. He was building apps for the Palm Pilot, one of the first handhelds that people actually used. He didn't just learn a new language, he jumped onto an entirely new platform that had barely existed a few years before. That's a huge leap.
The next pivot took him right into the high-stakes Berlin startup scene in the mid-2000s. And you can see the toolkit evolve again. Now we're seeing Java, Linux, and the super popular Ruby on Rails framework. He was now totally immersed in the open-source tech that was fueling the Web 2.0 explosion, building the kind of dynamic, interactive websites that we all take for granted today.
All right, so from that Berlin startup scene, the journey brings us into an era that we'd probably all recognize today. You know, the age of smartphones, app stores, and a completely different way of building software. By the 2010s, the focus had shifted one more time. This 2018 reference shows he spent years building apps for Apple's ecosystem, creating photo service apps for both macOS and the iPhone. The journey that started with mainframe terminals now meant his code was literally in the hands of millions of users on the world's biggest mobile platform.
Now this is so important. It wasn't just about learning new programming languages. The entire culture of how you build software had transformed. He had to master agile methods like sprints and scrums, collaborative coding on GitHub, and that whole DevOps mindset of continuous delivery. This was a transformation in process, not just in technology.
So how? How does one person navigate all of this? From COBOL to C++, from mainframes to mobile, from waterfall to agile. We've seen the what, but now it's time for the how. And the answer has been the one constant through this entire 35-year story. The secret isn't some magic bullet. It's actually something much simpler, but also much harder. It's a relentless, decades-long commitment to just learning. That has been the engine powering every single pivot, and the proof is woven right through his career.
Just look at this. On the left, you've got a certificate for a COBOL course from 1989. And on the right, a certificate for an advanced course in modern software architecture from 2023. 34 years apart, these two pieces of paper perfectly capture a career that's been defined by never, ever stopping the learning process. It's incredible.
And that learning wasn't just happening in a classroom. He was always plugged into the industry. In '99, he's at PalmSource, right when handheld computing was taking off. A decade later, he's at Apple's WWDC during the height of the iPhone revolution. You fast forward to today, and he's at conferences focused on AI and cloud architecture. He wasn't just keeping up. He was trying to see what was around the next corner.
And this isn't just about formal training either. It's a daily habit. He's listening to audiobooks about DevOps and AI while he's out for a run. He's tuning into cutting-edge tech podcasts like Latent Space while swimming. The learning is literally woven into the fabric of his daily routine. This is what continuous improvement actually looks like in the real world.
So all of this brings us right up to today. That learning engine is still running at full speed, and now it's focused on the next massive wave of technological change: AI and large-scale system architecture.
His current title is Director of Architecture and Innovation, and that job description really says it all. It's not about maintaining the old systems. It's about shaping the future, exploring cutting-edge tech, and getting the company ready for whatever comes next. After 35 years of reacting to change, his job is now to create it.
And today's toolkit is, once again, completely state-of-the-art. We're talking about cloud platforms like Kubernetes for managing apps at a massive scale, Terraform for automating infrastructure, and AI coding assistants like GitHub Copilot as a daily partner. It is a universe away from those washing machine-sized disk drives, that's for sure.
So this entire journey, from mainframe apprentice to AI architect, leaves us with a really powerful question. The last 35 years have been this incredible whirlwind of change. Looking forward, what skills are going to define the successful careers of the next 35 years? If this story teaches us anything, it's that the most important skill you can have might just be the ability to learn the next one.